Hey guys, this is James from CAD9 Design. Thought I'd do another retopology video. Um, I got a project. I can't really talk about the project, it's under NDA. This is sort of a joint venture with a client I really like of mine. And I do intend to kind of show a lot of this process, like go into detail the whole product development cycle for this thing. But I can't really do that yet. But I can't show the retopology because I'm not really going to be giving anything away. So this actually, this perfect model for doing this. It's a laser scan. It's nice and clean. Thank you, Idea Beans. Posted this on Thingiverse. He scanned it, and it's a good usable scan. Pretty typical of a good quality scan, but not typical of a laser scan. Usually they're a bit messier than this, but I don't really want to go into cleaning up scans at this point. We'll get to that sooner or later. I got some pretty nasty scans we can use. So anyway, just going to go through initially prepping this for retopology in this video. And then in the next video, I'll go into building this shell, some best practices there, how to do it all in Fusion 360. Even though I might do some of this in Modo, like in my normal workflow. A lot more people watching this probably have Fusion and don't have Modo, so I'll try and stick 100% Fusion 360 on this one. Also, while I'm rambling before I get into it, I've got a project that's going to make a good series coming up, doing a web shooter. There's this guy a while back called HeroTech on YouTube. I'll put a video link down in the description. And he's been making these web shooters, and he wants to do a small one. He already did one, just kind of a real basic one, 3D printed. He put up, and it got 7 million views or something. That's pretty cool. A little magnet on it and stuff. But anyway, he wants to kind of up his game a bit, which he's already doing without me, actually. He's making one that hopefully can support his weight. But we want to make a really high quality one. The last ones were cool. He sold a few of them on Etsy. They were 3D printed, but we want to make it machined and cast and all that, and as accurate as possible. So that could be a pretty interesting series, just going through the whole process from start to finish. And I was thinking of doing it as a live stream. I obviously wouldn't live stream the entire thing just because, that's just not really realistic. But I was thinking of doing a Saturday night live stream or something like that. A couple friends of mine to do a podcast with called The Makers. Maybe I'll have one or two of them on, make it a little more interesting. We can talk and have a beer or whatever. And it'd probably be an SFW if we do that. But yeah, let me know if you guys would want to see something like that as a live stream or would prefer it to be lessons like this. And I guess, yeah, let me know in the comments. And in the meantime, I'll get into this. Okay, so we have our model here, which I got off of Thingiverse. It's a laser scan of an Xbox 360 controller. It's a pretty nice quality scan. This isn't really a typical example. They're usually not this high quality. Usually got some outliers and stuff. We can do dirty scans later. But this one's really nice, and I need the basic outer shell shape. It's going to get altered a bit, but we kind of want it to be more like the 360 controller than the Xbox One controller. So that's going to be kind of the template. So I'll have to capture this shell. I won't have to get this guy here. A lot of this stuff's going to be different, but I still will want to get kind of the basic locations and forms, the buttons and stuff. And in a way that can be, parametrically edited later on. So first things first, we got our scan open and we want to check our scale. I know this should be about 150 millimeters. Well, we got 1531, so I'd say we got a 10x scaling error, which is pretty common. Okay, so let's scale this thing down. Actually, before I do, let's also look how we are in space. Of course, we're tilted at all three axes. Laser scans are never like straight and even, just the way it is. So we'll get this thing positioned, and we'll get this thing scaled. And I'm gonna go up here, scale it. Okay, now before I go any farther here, make sure you're in direct modeling. Well, you don't have to, but you're better off in direct modeling. This is the original source data. I don't like to change the source data, but I will scale it and I will position it. I will do this all in direct modeling, so I get a nice scaled, properly oriented mesh to drop into my actual file. I don't tend to use the original data in the actual file. I tend to either export it or just have it linked, kind of depending on the job. We'll scale this around the origin just because it's like the only actual like point in here. Pick the origin there as our point. And 0.1 scale. Okay, here we go. Let's check this out. Yeah, that's more like it. That I would say is right. And usually that's like a centimeters to millimeters scaling error, or millimeters to centimeters. Okay, let's close this here. Now we need to orient this thing. We really don't have any straight lines or anything like that. We do have the bottom of this. That's a straight line, but it's not like a plane. It's nice if you have a flat, wide plane somewhere, but something like this, we got no flat surfaces really. We got the circles established by these, theoretically. Yeah, no real flat surfaces, so this is kind of ideal. Now I could line this up. Let's say we got top's good. Let's see if that's front. Oh yeah, cool. Could line the bottom up with that. That's nice and straight, but actually I think I'm going to try to line this up and this, so like it's naturally sitting on the ground, just for the sake of making renders a little simpler. Like it'll actually be sitting on the floor or whatever, kind of naturally. Actually, no, I take that back. I would do a separate render model, I think, if I do that. Because if I line this up here, this looks like it's parallel to these guys. So all my buttons are actually going to be like flat and parallel to, my ground plane. That's what I'll do. We got about 153 millimeters or whatever. From here to here is 109. So let's say that's going to be like 90 or something. So I'm going to do like 150 by 100 bounding box to position this off of here. Then here, this, I'll use that to get position. And let's see what I can get from the front here. I can pick up this sharp line right here. And that's all I can use to kind of get all my pitch and yaw right. Okay, so here we're going to create a sketch. And we're going to do a center rectangle off the origin. And what did I say? 150. And we can tweak this if we want later on. But 150 sounds good to me. 100. There we go. Now we can, because we're direct modeling, we can scoot this around and eyeball it and edit this sketch and all that kind of stuff, and we don't have to worry about like if we go back to edit this sketch, this thing's going to stay wherever we moved it to. That's one of the reasons I do this in direct modeling. Where if we're capturing a design history and I right click and edit sketch, it's gonna, this is gonna be in this position past where I started the sketch. So let's stop our sketch here. Top view, move copy, pick this guy, and we'll just eyeball kind of the center there. I'll tweak that sketch to really capture the boundaries. And then I'll be able to drop this thing in there really straight and really nicely centered. Without, let's see here, edit sketch. Say, without losing that position. Let's say 155, 155, call that. Well, I was way off there. I thought that said 109 before. It's probably because it's all tilted and stuff. Let's call that 110. Okay. By the way, if you get a big mesh here, it will try to misbehave a bit on you. Fusion doesn't like all those. I don't know if it reads those all as selected faces or what, but when you select a mesh in Fusion, it tends to kind of not like it when the mesh gets too heavy. Okay. So now let's create ourselves another sketch here. I'm going to do another center rectangle. You may see a trend starting to emerge here. Okay. Put a point along the center there. And snap that to there. Height. I probably want to capture from this to this. So that's 60.4, whatever. We'll call that 60. Okay, so let's do another move copy. Okay, we're getting close. We'll give it a little tip here. And what we're trying to do is line the bottom, this bottom surface up with this line here. So maybe 10.5, and we'll kind of home in on this. When you're doing this, this is the part you really want to take your time to do right. Like, you'll be able to fudge remodeling a lot of these surfaces, but like your whole kind of frameworks can be built off your coordinate system. So you want to take the time to get this as right as you kind of practically can. Sometimes it's impossible. Sometimes you have to make judgment calls. On a nice clean scan like this, it's not so bad though. Oh yeah. And let's move that a hair more. Now I've got this lined up kind of right how I want it. Let's have a look at that. Yeah, that's pretty dang close. Okay, so we're getting there. Now, we've got to rotate it along here, and then we're good. We don't really need a bounding box there, but I like one just to kind of have the visual reference. So let's create a sketch and do our Center rectangle again. Make that midpoint. Then you can drag this guy around. And here you can try midpoint. And it works. If not, then I just go to coincident there. I'm not sure what we don't have locked down here. Oh, I see. 3D. It's snapped to this guy in 3D. Okay. Let's turn off 3D. And midpoint. There we go. Huh. That's a glitch. That should, if you unsnap 3D, it shouldn't be able to grab that. Okay, Fusion. That's something you gotta figure out. So we can do this here then. Project. Grab that point, hit enter. Okay, now give that a midpoint. Okay, so there's kind of our bounding box. And I'm actually, trying to line this up, right? So what I'll probably do is eyeball that. Well, actually, maybe the center point's here. I'm going to straighten this out and kind of see what it looks like. And this is where we start getting a little bit more exact. Okay, we want to do this body here, right? Now, though, since we're kind of close, we want to start setting our pivot on the origin. Oh, whoops. Let's check mark it first. We want to set our pivot around the origin since we're getting close. See, now, let's say -5 here. Oh, nice. See, now we can start also seeing how we got to line it up in the other directions. Like this needs to be, I don't know, -2. Let's try -2 millimeters. That's pretty close. Let's say that's -1.9. See, I'm trying to get these gaps like right on. That's really close, tiny bit closer there, but I think I'm going to get the size of the square actually like a little bit closer to really get that. And it looks like I still might have a little bit of tilt here, but I can't really tell. Before we get out of this feature though, let's see how close we are in other directions. Okay. Boy, Fusion's really not liking having this thing selected. Joint and move are like the two slowest features when models start getting complicated, I've noticed. Like the Marble Machine X video, the Marble Machine X model I used in the other video, like that thing, like you can't like do moves in it. It thinks for like 20 minutes before it does it. Theoretically you can, but practically, no. We're looking pretty good that way. So I'm going to hit OK there. I'm going to tweak the size of these bounding boxes. And I know I probably seem like I'm being a little too picky here. But this is really the place to do it because everything's built on this. Like when you're like, this is your foundation and you're going to build your part around it. You want to do a good job on your foundation. We don't really care. Like if this contoured surface is off 10 thousandths of an inch or 20 thousandths or whatever, It's not the end of the world. You know, that's kind of like, you know, an inexact shape, I guess you'd say. But when it comes to like your work coordinate system, when it comes to like, you know, if I've got like screw bosses and stuff in here, you know, I really want everything parallel and square and everything like that as much as absolutely possible, because it's like this is what all my features are going to be built on. So like a 2% inaccuracy at this stage is going to kind of compound downstream, where like when I'm modeling this skin, there's not really going to be anything downstream of that except the thickness, you know, the shell feature or whatever. You know, and I'm not going to be dimensioning anything off of like an area of this, like this shell. So you want to kind of start out being super OCD about getting everything accurate, and then gradually you can get lazier and lazier as you go along. Um, but when you are doing this, kind of the main, okay, I'm going to stop modeling for a minute. I'm going to ramble. Tolerances in retopology. I see people on YouTube constantly misplace their efforts on their tolerances. This part's a bit of a challenge. They'll eyeball it. They'll say good enough. Then they'll try to capture, you know, things like too exactly. You don't see that quite as much on YouTube, but you do out in industry. Like so many people, their parts don't look quite right, and it's because they try to stick too closely to the laser scan or whatever, and they start introducing some inaccuracies from the scan. And a lot of people will be like, oh, well, that doesn't have to be, you know, like contour thing. It doesn't have to be too super exact or whatever. And sometimes they're right, sometimes they're not. But I constantly see people kind of misguess where their tolerances need to be. You can spend way too much time being way too accurate on a retopology. You can also really, like by not being dead accurate in the right place, you can really cause a lot of downstream problems and a lot of headaches. It takes some experience on, you know, different types of jobs before you can kind of learn where you need to spend your time. But this is a tedious, time-consuming process, retopology. It's not for the impatient. It's you can waste a whole lot of time. Like say if I got this half a degree off, like this thing was tilted a half a degree off. So this guy is like a half a degree lower, and this guy is like a half a degree higher from, you know, that center off of where it should be or whatever. So this little bit's a little bit higher, this little bit's a bit lower. Okay, now when I'm modeling, I want to make a mirror plane, right? So I have to mirror a feature from here to here. Now, because these aren't exactly the same size and the same position, I've gone ahead and modeled these up, kind of where they are, you know, eyeballing it or whatever. And then I've got some screw bosses here or something. And then I have to have a PCB in here. Everything's going to line up and stuff. Well, if my screw boss is like, if this center point and this center point, I mean, it looks like they ought to be lined up, right? And they probably are. But for the sake of argument, say there's like a little bit of an offset, like a millimeter. The center point of this whole feature is a millimeter higher than the center point of this feature. And I've tilted it, and I've minimized that. And I've made the assumption, you know, when I mirror these screw bosses or whatever, and they're close enough to where I've made the assumption that they are level with each other in X and Y. And my screw bosses are level or whatever. And so now my PCB is like designed off of, you know, these being fully mirrorable like features. I don't know if that makes sense. I don't know if I'm explaining it right. So when I actually go to make the part, like things just don't quite fit together right, because these screws are locating the PCB, and the PCB is sitting under these buttons, and like in the CAD these are kind of like parallel to this horizontal line. And in reality, there's like a 1 millimeter offset I've missed. All that stuff becomes more obvious if I take some time to really make sure that mirror plane really is as dead center as it can possibly be, because everything mirrored there is going to kind of double. Like, it's inaccuracy. Like this, if I mirror this and my mirror plane's a 0.5 millimeter off center, this is going to be a millimeter off, right? So you really, the places you really want to expend your time and effort is your foundational features, your work coordinate system, your hole locations, feature locations that that are hard and need to change. This thing has has some nice guides. Fortunately, some models it's harder. If the scan's not quite as clean, you got to make some judgment calls. But sometimes you do have to go back and say, well, no, this I can't do it off of this scan or whatever, because a critical area is missing or is just inaccurate. That's a pretty common occurrence. So you really want to spend your time on that stuff. You don't want to spend so much time getting these contours and stuff right. Ironically, these are some of the easiest to get right once you learn what to ignore. We'll get into that more when I'm actually building those surfaces. That's where people spend too much time on it. They go, okay, they mistake precision for accuracy, and they very precisely try to follow that laser scan surface as much as possible. And they create more work for themselves, and their results don't look as good. Now, in this whole process, when you're doing retopology, you've got to keep in mind manufacturing tolerances too. And you have to make sure you are accounting for like your stacked up manufacturing tolerances. So if this is all going to be like rectilinear machine things, typically you're going to be able to kind of get a class of tolerance a little bit tighter than this contoured kind of stuff, but in functionality, those also tend to be the most rigorous. So you want to get those pretty much dead nuts, because like if you got a plus or minus 5 thou or like 0.1 millimeter or whatever tolerance on the manufacturing, you really got to model that in the right place, because you're plus or minus 5 thou, you've lost plus or minus 5 thou in the retopology. So it kind of has to be there, as much as possible, because you're not gonna hit a 5 thou tolerance and like going off a scan. You're not going to. So you're gonna do your best. You're gonna make your prototype, and then you're gonna see what went wrong, what you've got to change. Well, the better you do, the more chances you are hitting that first prototype right, or at least close enough to where maybe if this is a 3D print or whatever, it's a little bit of work with a file or sandpaper instead of having to do a whole nother print. So there's an art to tolerancing your retopology, and I'll go as it's relevant at the various stages of modeling this. I can go into that. It's going to be really important to get whatever is rectilinear in this thing as dead nuts to your work coordinate system as possible. So, like stuff like this here. I actually want to take the time to like measure that and measure that, see where we're at. So it's like that corner, that's a nice hard point, like that I can find on this side pretty easily, or this little spot right here. So if I measure from that line, I got 40.153, and this is nice because this line's actually tilted like that, so it's kind of expanding, I guess, the inaccuracy. What was that 40 point? Let's try that again. Actually, no, actually I don't want to grab that in 2D. I want to do this in 3D in case I'm grabbing farther or probably this is going to be a better point. Actually, yeah, that's going to be a better point. Because I can easily go a little farther forward or back. And grab this line. So I got 41.624. So let's grab that here. Grab that. Oh, whoops. Grab that here. 41.747. That's, you know, that's close. That's really nice. That's good, actually. Pretty happy with that. That doesn't mean we're done. But that's not bad. Okay, so we got a little bit more gap here than here. I'm going to edit some of these dimensions. Let's take that down to 50. Too much, so say 55. It's about right. Stop sketch. And now to keep from chasing my tail, I just do one move at a time. Meaning I'll move this up in, what is that, Y? Z? Up in Z. Get that right, get that tweaked in, then, you know, maybe work on the rotation. At this point, you're close enough to where you want to work on one thing at a time, so you don't like spend a bunch of time readjusting. Oh, a little to the left, a little to the right, you know, like that. And if I'm rotating, I want to go ahead and set my pivot point around that center. It's just nice to keep your center of rotation kind of in the same general area. That's why I do this center rectangle bounding box thing. So I've always kind of got this center of rotation for the whole model. I bet you didn't think positioning would take this long. Now, the thing is, I'm showing you how to do this in Fusion. I got a script in Modo by a designer I really like called Josh Mings. Does CAD Junkie and Solid Smack and stuff. A script in Modo to find a center plane and scale and all this kind of stuff. A mesh, that's really nice. But yeah, most of you guys probably aren't paying for Modo. So, you know, I'm going to do this all in Fusion. This gets slow when I'm recording and I got OBS going. I need to build a new system. Actually, that would be a cool video series. If you guys want to see design from the ground up. Well, that actually wouldn't be from the ground up because they based it on a case already designed. I designed this computer case for a company called Singularity Computers called Spectre. It's like basically a big water block case. Like it's like the whole thing's a water, like a liquid cooling kind of manifold. I want to do a custom one for my own system. Is that something you guys would like to see? It'd be like some CAD, but also a lot of like physical meat space type work. I don't know if that's like a direction people would want to see this channel going or not. I think it'd be pretty cool though. Hey, look at that. Let's do 0.4. Yeah, and I could just build a CAD workstation on here. Yeah, it's a pretty cool case. There's let's say 3.5. If you go to Singularity Computers website, you can see it. Yeah, that's a shameless plug for one of my designs, but I'm really happy with it. I worked on that, like I ate, breathed, and slept that for like 100 hours a week for like 6 months. So I feel a little bit justified. So see here, I'm seeing I'm gonna have to kind of tilt things a little bit. Tilt that like 0.1 degrees. See where we're at. Oh, yeah, it'd help if I grab the degree thing, right? So 0.1. So I'm going to edit a lot of this out. I'm going to basically tweak the rotation in all three axes and tweak the alignment in all three axes and tweak these dimensions so I kind of get my nice bounding box. This thing's going to be very handy later on just to kind of have references to grab onto. Okay, so yep, I'm going to edit this and get this in position. That's kind of going to be it. Okay, here you can see I'm moving very small increments. And what I'm looking at is this center line along here. And that looks pretty dead nut straight to me. I'm happy with that. But I have to go right down to these increments, these fine increments. Now there's a tiny bit of inconsistency there, but that's probably from the laser scan. You kind of have to take it like you kind of have to gauge all the features. Like in something like this, if most of your features look symmetrical and one's a little off, it's probably an inaccuracy in the scan. You kind of have to make a best guess there. Fortunately, this is a really nice clean scan. Thank you, Idea Beans. This scan's beautiful. Okay, we're looking really close there. Quite happy with that. Okay, I'm going to have one last look at this here. I think I'm happy with this. So now we have our mesh model quite nicely straightened and centered and all that. We have really more than we need as far as sketches go, features here to orient off of and draw off of. If I leave this in here, I can I've got kind of a handle. I can model this this plane's parallel to the plane of all these controls here, but then I also have a handle where I can make a joint with like the origin and one of the axes or whatever in like a render model and give that a particular degree of tilt. So my ground plane lines up right here or whatever. So I'll probably leave these in as handles for this one because I really don't have much to go off of there. So yeah, that is that for actually no, that's not quite that. That's almost that. Okay, now I'm in my controller file. I will bring this in here. And hit OK. That should be located nicely. Origins match up. Everything's lined up. Sweet. The sketches are just kind of there for visual references. I can hide those until I need them. Yes. Okay. Do a get latest. And yeah, there we go. So I'll pretty much always take my source data and drop it into a different file for design. That way, if this is nasty and messy and huge, I can suppress it or I can delete it and not affect my model. And then I can always drop it back in if I have to. Also, it's just good practice. What if I accidentally deleted the design file? That would suck. It would suck even more if my only nice clean copy of the retopology data is deleted along with that. So yeah, I'll keep that separate. I'll even export it a lot of the times, just so I have a properly scaled and oriented version of. It's like a lot of times what I'll do here. Okay, so I'm not going to show this, but typically my workflow is I take my mesh into Modo first, and maybe I'll reduce the poly count or whatever, kind of clean things up a bit, do my aligning things up, and then I'll bring it in here. So that is now a nice cleaned up file. Let me know if you guys have any questions down in the comments. I can cover it in the next video. Next, I will start actually doing some modeling here off of this. And I take a little bit of an approach to retopology for contoured stuff that's different from most people. So hopefully you learned something. Thanks again, Ideal Beans. Cool model. Nice job. And talk to you guys later.